Deep learning is a powerful type of artificial intelligence. It allows computers to learn from data. This is similar to how humans learn from experience. Imagine a computer program that can recognize objects and images. This program can identify cats, dogs, cars, and more. Deep learning makes this possible. It helps computers understand the world through examples. Deep learning is a subset of machine learning. Machine learning is a broader field of artificial intelligence. Machine learning focuses on algorithms that improve with experience. Deep learning takes this a step further. It uses artificial neural networks to process information. These networks are inspired by the human brain. Deep learning algorithms excel in handling large amounts of data. They can find complex patterns and relationships. This makes them suitable for various tasks. These tasks include image recognition, natural language processing, and speech synthesis. Deep learning is revolutionizing many industries. These include healthcare, finance, and transportation. In the following sections, we will delve deeper into the world of deep learning. We will explore its importance, applications, and inner workings. Join us on this exciting journey to uncover the potential of deep learning. Deep learning is transforming our world at an unprecedented pace. Its ability to analyze vast data sets and extract meaningful insights is revolutionizing various fields. From healthcare to finance, deep learning is driving innovation and solving complex problems. One of the key reasons for deep learning's significance is its ability to automate complex tasks. For instance, in medical imaging, deep learning algorithms can detect diseases like cancer with higher accuracy than human doctors. This early detection can save lives and improve patient outcomes. Moreover, deep learning is enhancing customer experiences in numerous ways. Recommendation systems powered by deep learning personalize our shopping experiences. Virtual assistants like Siri and Alexa use deep learning to understand our voice commands. These applications make our lives easier and more enjoyable. Furthermore, deep learning is playing a crucial role in advancing scientific research. Scientists are using deep learning to analyze climate patterns, discover new drugs, and even explore the universe. The ability of deep learning to process massive amounts of data is accelerating discoveries in various fields. In conclusion, deep learning's ability to analyze data, automate tasks, and drive innovation makes it a transformative technology. Its impact is being felt across industries, improving our lives in countless ways. Deep learning is no longer a futuristic concept confined to research labs. It is actively shaping our present, powering a wide range of applications that we interact with daily. Let's explore some real-world examples of deep learning in action: image recognition. Social media platforms use deep learning algorithms to automatically tag our friends in photos. E-commerce websites utilize deep learning for visual search, allowing us to find products based on images. Self-driving cars rely heavily on deep learning for object detection and navigation. Natural language processing. Virtual assistants like Siri and Alexa understand our voice commands thanks to deep learning. Language translation services leverage deep learning to break down language barriers. Chatbots powered by deep learning provide instant customer support on websites. Healthcare. Deep learning algorithms assist doctors in diagnosing diseases from medical images. They can analyze medical records to identify patients at risk of developing certain conditions. Deep learning is also being used to develop personalized treatment plans for patients. Finance. Banks use deep learning to detect fraudulent transactions and prevent financial crimes. Investment firms leverage deep learning to make more informed investment decisions. Deep learning algorithms analyze market trends and predict stock prices with increasing accuracy. These are just a few examples of how deep learning is transforming various industries. As deep learning technology continues to evolve, we can expect even more innovative applications to emerge, further enhancing our lives. At the heart of deep learning lies a fascinating concept inspired by the human brain: artificial neural networks. These networks consist of interconnected nodes, or neurons, organized in layers. Each connection between neurons has a weight associated with it, representing the strength of the connection. The learning process in deep learning involves feeding the neural network with vast amounts of data. As data flows through the network, the weights between neurons are adjusted to minimize errors in prediction. This iterative process of adjusting weights is called training. During training, the network learns to extract features and patterns from the data. For example, in image recognition, The network learns to identify edges, shapes, and eventually complex objects by adjusting the weights of connections between neurons. The depth in deep learning refers to the multiple layers of neurons in the network. These layers allow the network to learn increasingly abstract representations of the data. The more layers a network has, the more complex patterns it can learn. Once trained, a deep learning model can be used to make predictions on new, unseen data. The model processes the input data through its layers of neurons, using the learned weights to arrive at a prediction. The accuracy of these predictions depends on the quality and quantity of data used during training. In essence, deep learning empowers computers to learn from data in a way that mimics the human brain's ability to recognize patterns and make decisions. This powerful capability is driving innovation and transforming various industries. Section 5. Neural networks, the building blocks of deep learning. Imagine, if you will, a complex web of interconnected nodes, each node representing a tiny computational unit. This intricate web, known as a neural network, forms the backbone of deep learning. Inspired by the biological neural networks in our brains, these artificial networks are designed to mimic the way humans learn. Each node in a neural network receives input signals from other nodes. These signals, representing data points, are then processed by the node using a simple mathematical function. The output of this function is then passed on to other nodes in the network. The connections between nodes, called synapses, play a crucial role in the learning process. Each synapse has a weight associated with it, which determines the strength of the connection. During training, the network adjusts these weights based on the input data, strengthening connections that lead to correct predictions and weakening those that result in errors. This iterative process of adjusting weights allows the network to learn complex patterns and relationships within the data. By analyzing vast amounts of data, the network gradually refines its internal representations, becoming more accurate in its predictions over time. Neural networks come in various architectures, each tailored to specific tasks. For instance, convolutional neural networks excel in image recognition, while recurrent neural networks are well suited for processing sequential data like text or speech. In essence, neural networks provide the computational foundation for deep learning, enabling computers to learn from data and make intelligent decisions. Their ability to process vast amounts of information and extract meaningful patterns makes them a powerful tool for solving complex problems. Section 6. Layers of understanding, delving deeper into neural networks. The true power of neural networks lies in their layered structure. A typical neural network consists of an input layer, one or more hidden layers, and an output layer. Each layer plays a distinct role in the learning process, gradually transforming the input data into meaningful representations. Input layer. This layer serves as the entry point for data into the network. Each node in the input layer represents a single feature or attribute of the input data. For example, in image recognition, each node might represent the pixel value of an image. Hidden layers. These layers lie between the input and output layers and are responsible for extracting features and patterns from the data. Each hidden layer consists of multiple nodes, each performing a simple mathematical operation on the input it receives from the previous layer. The number of hidden layers and nodes in each layer determines the complexity of the network. Deeper networks with more hidden layers can learn more abstract and intricate patterns, but they also require more data and computational power to train effectively. Output layer. This layer produces the final prediction or classification based on the processed information from the hidden layers. The number of nodes in the output layer depends on the specific task. For instance, in a binary classification task, the output layer might have 2 nodes representing the 2 possible classes. The layered structure of neural networks allows for a hierarchical learning process. Each layer learns to detect increasingly complex features, building upon the representations learned by the previous layers. This hierarchical approach enables deep learning models to handle complex tasks that were previously considered challenging for traditional machine learning algorithms. Section 7. Inspiring innovation, cool projects, powered by deep learning. The advancements in deep learning have fueled a wave of innovation, resulting in groundbreaking projects across various domains. Let's explore some cool projects that showcase the transformative power of deep learning. Deep Dream Generator, developed by Google, Deep Dream is a computer vision program that uses neural networks to enhance and manipulate images. By amplifying patterns detected by the network, Deep Dream creates surreal and dreamlike imagery, offering a glimpse into the inner workings of artificial intelligence. Style transfer. This technique uses neural networks to transfer the artistic style of one image to another. By separating the content and style of an image, deep learning algorithms can combine the content of one image with the style of another, creating unique and visually appealing results. Text generation. Deep learning models like GPT-3, Generative Pre-trained Transformer 3, can generate human-quality text in response to prompts. These models have been used to write stories, poems, and even computer code, demonstrating the creative potential of artificial intelligence. Music composition. Deep learning is being used to compose original pieces of music. By training on vast data sets of existing music, neural networks can learn musical patterns and generate new melodies, harmonies, and rhythms. Drug discovery. Pharmaceutical companies are leveraging deep learning to accelerate the drug discovery process. Deep learning algorithms can analyze molecular structures and predict their properties, potentially leading to the development of new drugs and therapies. These projects represent just a fraction of the exciting innovations powered by deep learning. As research and development in this field continue to advance, we can expect even more transformative applications to emerge, shaping the future of various industries. Section 8. The Future of Deep Learning. A Glimpse into Tomorrow. The field of deep learning is constantly evolving, with new breakthroughs emerging at an unprecedented pace. As we look ahead, the future of deep learning appears incredibly promising, with the potential to revolutionize countless aspects of our lives. Enhanced personalization. Deep learning will continue to enhance personalization in various domains, from personalized medicine to customized education. Imagine a world where healthcare plans are tailored to our unique genetic makeup, and learning experiences are adapted to our individual learning styles. Smarter automation. Deep learning will drive the development of smarter automation, leading to increased efficiency and productivity across industries. From self-driving cars to intelligent robots, deep learning will automate complex tasks, freeing up human workers to focus on more creative and strategic endeavors. Breakthroughs in healthcare. Deep learning holds immense potential for revolutionizing healthcare. From early disease detection to drug discovery and personalized medicine, deep learning will continue to transform the way we diagnose, treat, and manage diseases. Sustainable solutions. Deep learning can contribute to a more sustainable future by optimizing energy consumption, improving resource management, and mitigating the effects of climate change. By analyzing vast data sets, deep learning algorithms can identify patterns and insights that can help us address pressing environmental challenges. Ethical considerations. As deep learning becomes more powerful and pervasive, it is crucial to address the ethical considerations associated with its use. Ensuring fairness, transparency, and accountability in deep learning systems will be paramount to building trust and preventing unintended consequences. The future of deep learning is brimming with possibilities. By embracing its potential while addressing the ethical considerations, we can harness the power of this transformative technology to create a better future for all. Section 9. Conclusion. Embracing the transformative power of deep learning. Deep learning has emerged as a transformative technology, revolutionizing industries and reshaping our world. Its ability to analyze vast data sets, extract meaningful insights, and make accurate predictions has unlocked new possibilities across various domains. From personalized experiences to smarter automation and groundbreaking scientific discoveries, deep learning is transforming our lives in countless ways. As the field continues to evolve, we can expect even more innovative applications to emerge, further enhancing our capabilities and pushing the boundaries of what's possible. However, with great power comes great responsibility. As we embrace the transformative power of deep learning, it is crucial to address the ethical considerations associated with its use. Ensuring fairness, transparency, and accountability in deep learning systems will be paramount to building trust and preventing unintended consequences. By fostering responsible innovation and collaboration, we can harness the full potential of deep learning to create a brighter and more equitable future for all. The journey into the world of deep learning has just begun, and the possibilities are limitless.